Hi everyone, so this is day 2 of lesson 2, which was the elimination round, right? Elimination round. We are here on page 160, M2 160, and we're just going to do a whole bunch of problems. We're just going to solve by elimination here. All right, so here if you look at the first one, we can either choose to eliminate x or y, and it looks like here it's much easier to eliminate x, y, since both the coefficients are the same. They're both 2y and 2y. We just can't add them up like that because 2y plus 2y is 4y. We want them to cancel out. So we're going to have to multiply either the top or the bottom by -1. In this case, we just multiply the top by -1. And so we would get this answer, and then we cancel out the y's. So -5x plus 3y is going to be -2x is equal to -10 plus 6, which would be -4. And then from there, you would divide by -2, and your x would be equal to 2. And then you're going to just plug this right in. We use the first equation. You can use the second equation. It does not matter. We'll give you the same answer. And so we plug it 2 in for x, and then you do your order of, you solve, and then you get y is equal to 0. So your answer is going to be 2, 0. And then if you look at letter B, we decided we're going to get rid of y here, right? And the way we're going to get rid of y, if you notice, 3 and 2, they're not the same number. So what we're going to do is we're going to think to ourselves, what number will 3 and 2 both go into? So we're like 6. So if you think back to your elementary school days, you think of LCM, right? The least common multiple. So what number do both of these numbers go into? That's what that is. So it all comes in handy. So here is your -2. So we're going to multiply the 3 by -2 to get that to be a 6. Not just a 6, but a -6. This negative could be with the 2 or the 3. It does not matter. But we just decided to leave it with the 2. And then we're going to multiply the second equation by 3. The reason being so that we could get 2 times 3, which would be 6. All right. And so once we do all the multiplication here, this is what you would get. Please, again, if you did not try this on during class time, make sure you pause it and then try it yourself. All right. And then see if you get what I get. And if not, then you need to take a look at what happened here. All right. And again, if you still have questions, just let me know either in class or during office hours, or email me. And again, make sure you multiply the 3 on both sides of the equations as well as the -2. That's usually one of the most common errors that people make. They just multiply it on one side, but not on the other side. But that would be uneven. It would not remain equal. So yeah, that's wrong. And so once we multiply them out, now see how the 6's cancel out. We have -6y now and +6y. So that cancels out, and all we just get or eliminates. And we get -2x plus 15x, which is 13x. And as you can see here, we get x is equal to -9 over 13. It's not a pretty number, but it's the number we have. All right, and then once we plug it in, we can plug it in either to the top or the bottom. We've decided to just plug it into the top equation, the first equation right there. So here's x plus 3y is equal to 15. In order to get rid of the, because I'm like, you want to get rid of the fraction? I'm like, yeah. So we're going to get rid of the fraction by just multiplying both sides by 13. And the reason why we chose 13 is because that's what the denominator is. So if we can cancel out this 13, then we would have like no fractions, right? And so we're going to multiply everything by 13. So we get -9 plus 13 times 3, which is 39y, is equal to 13 times 15, which is 195. All right, and then again, we're going to just solve for y like we normally do, add 9 to both sides, and then divide by 39. And we get y is equal to 68 over 13. Please make sure you always simplify whenever you can. Okay, so then our answer is going to be -9 over 13 and 68 over 13. Okay, and here we tried instead, this was, well, what if we want to eliminate x instead? See here, someone had said, let's eliminate y. We could have just as well eliminated x, right? So if you notice right here, let's just do that really quick. And just put a little like line there. If you look at that really quick, notice that the bottom number is already just 5x and the top is just x. This makes it a little bit simpler because we just need to multiply the top by -5. And then they would be additive inverses, right? Actually, the x's would be additive inverses. So we would get, I don't have pink any, oh, kind of pinkish. So do you see what I did? I didn't multiply the -5 all the way across. So make sure you do that. So -5x, that would be -15y is equal to -5 times 15 is going to be -75. And then we get 5x plus 2y. We're just copying it down. It's equal to 7. X's cancel out. So what do we have left? So this would be -13y is equal to, we subtract that, that's going to be -68. And then we're going to divide both sides by -13. And then y is equal to just 68 over 13, which is what we said we would get. And then we would, again, remember, we will plug it into the y into the either the first or second equation to figure out what x is. But since we've already done that, I'm not going to go, we've done substitution like that before. All right, and if you look at letter C, we did not do letter C, as you can tell. So I'm going to put out a little bit of space here. This is going to be for C. We're going to do it here. So since you didn't do it, I think this would be a great time to try it out. So think to yourself, are we going to eliminate the x's or the y's? And for me, I think the y's have a slightly smaller numbers, so we're going to go with that. And I noticed that the 3 and the 2, 6 goes into both of us. 3 and 2 both go into 6. So I'm going to multiply the top number by 2, right? And I'm going to multiply the bottom number. Let's make that orange. And multiply the bottom number by -3. I'm putting the negative on the 3 this time because these numbers look a little smaller. So I'm trying to avoid negative answers here. So again, on the top, we're going to have 2 times 4x, which is going to, here's my line right here. This is where I draw the line. So it's 8x, and then 2 times 3x, which is going to be 6y. I meant 2 times 3y is going to be 6y. And then 2 times 12 is going to be 24. We're going to do the same thing with the bottom. So -3 times 3x is going to be -9x. -3 times 2y is going to be -6y. And then the last one is going to be -12. Now we go into our adding. So notice 6y and -6y, those are additive inverses, right? They cancel each other out. So what do we have? 8x minus 9x is going to be minus x is equal to 24 minus 12, which is 12. How do I get rid of that negative? Oops. I'm just going to divide both sides by -1. And so my x is equal to -12. That looks like a very strange -12, but it is -12. And so now we're going to either put that in the top or the bottom equation. Let's use the bottom one because it looks a little smaller. So again, we're going to put 3 and then -12 in for x plus 2y is equal to 4. Remember this? I'm just using the second equation here. All right, I'm going to just simplify and then solve for y. So this is going to be -36 plus 2y is equal to 4. How do you get rid of the -36? You add 36. So we get 2y is equal to 40. They're very close. Get rid of the 2 by dividing both sides by 2. And you get y is equal to 20. And so here our answer would be -12, 20. So if we were to graph these, it would these two lines would intersect at -12, 20. So let me pull up my Desmos and see if that's what we get. There we go. I'm going to just, so it's going to be 4x plus 3y is equal to 12. All right, just like that. And then 3x plus 2y is equal to 4. So we're saying that intersects at -12, 20. So we're going to go over here. So do you see how they do? Looks like they're going to cross. Oh, right here. See where they cross? See, look, -12, 20. See what I said? So yeah, that is exactly where we said it was going to cross at. So there we go. That is the visual check for that. Just like we said. So if you take a look at these ones, we decided which one we were going to eliminate. Again, for good practice, you can eliminate the other one. Instead of y, do x. But honestly, I would always try to see which one is easier. Is it easier to eliminate the x, or is it easier to eliminate the y? So here, I'm going to just highlight these. This is what we said. And I wrote them right above. What I noticed right here, you see a pattern? All the left ones were eliminate X, all the right ones were eliminate Y. All right, so if you look right here for the A, yeah, we can straight away, the X's are additive inverses of each other, so you can just cancel those out. And we could be like, okay, 5Y is equal to -65, right? And divide both sides by 5 to give us -13. And again, you're going to just plug that in. We plugged it into the first equation. You could plug it into the second one. It does not matter. And the Y is just going to be right here at, let me see here. Let me make that different color. So this Y, 13, is going to go in right here for the Y. And we use the original equation. Well, let's see here, X, right here, that one right there, the first one. And then we're going to just solve for X. And we get, I would say the only tricky part here is remember with the 1/2 multiplied by the reciprocal, in this case, which would be 2/1, or you could have just done 2, since 2/1 is 2. And then you get the answer of -220 and -13. And please make sure you write this as an ordered pair, just like that. All right, ordered pairs have to have those parentheses around it to show, hey, this is an ordered pair. All right, and then for B, if you notice right here, I always like to look for the coefficient with no coefficient in front, which means that's the number is 1 in front, because those ones I only have to multiply one equation as opposed to both of them. A little bit less brain power. And if you notice here, I am just multiplying by -3 because the other coefficient is just +3. So if this was originally a -3 or a -3, then I would just multiply it by a regular 3. Okay. And again, so I rewrite both the top and the bottom equations, and then I'm going to cancel them out. I get -5x is equal to 30. And then, x is equal to -6. And again, we're going to just plug that in. All right. Once you do all the work, you should get this as your answer, -6, 16 as your answer. All right. And taking a look at C. Again, there's no real like, oh, you should eliminate X or Y. They're both kind of similar. So I would just stick with X just because those are going to be require smaller numbers. You could do either one though. And so again, what number does 3 and 2 both go into? 6. We have 6s for days today, right? So we're just going to use 2 and -3 to get the coefficients to be 6. Make sure you're multiplying all the way to the end, even to after the equal sign. That's why I included that in the parentheses, right? And so you should get these as your answers. And once you cancel that out, you get 10y minus 9y, which means you just get y, and it's equal to 1. So we don't have to divide by any because it's just y. We already have the answer for y, so we're going to plug that in. And here we use the first equation, but you could also use the second equation. Lots of choices here, all right? Because it'll work for both. And so your answer should be 4, 1. All right, and then we did D here. So here we decided to eliminate y just because that y is by itself. And so we're going to multiply everything by -3. And if you notice here, they both cancel out, right? If they both cancel out, the x's and the y's both cancel out, all we have left is a 0. And does 0 equal 2? That's not true. So whenever this happens, like we had said before, that means it's no solution. So if we were to graph these, this is what it would have looked like. So this is what was here before. So this is your 6x plus 3y is equal to 5. This is your second equation right here. And notice they're parallel. Are they ever going to cross? If they're never going to cross, and if I ask you, well, where do they cross? You'd be like, they don't. And so that's what we call no solution. There is no solution. Okay, there is no point that works for both of these two equations. You're not going to find it. And same thing with this over here. So let me delete those guys. If you look up this one, notice the x is the one that has the no coefficient there. So we're going to multiply that top equation by -2. And when we do that, you'll notice that, ooh, the x's and y's both cancel out. But then we also have our numbers, they cancel out. So all we have left is 0 equals 0, which means that we have infinitely many solutions. So what in the world does that look like? So we've got x plus 2y is equal to -6. Okay, let me go back to, okay, so that's what that looks like. So now let's try the next equation. 2x plus 4y is equal to -12. And if you notice, they're the exact same line, right? Green, blue, same thing, exact same line. They're like one on top of the other, right? Which means at what point do they intersect? Like, well, all the points, like there's not one time that they don't intersect each other. Like they're always intersecting because it's the same point. So any point that works for one equation will work for the other equation. So this is what we call infinitely many solutions, because it could be here, 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 here. It could be any of these, right? So that's how that's going to work. All right. Hopefully this will help for you. Please make sure you practice. I will see you later.